Welcome to everyone. In this video, we are going to learn hyperbola in general method. Hyperbola in general method. The question is construct a hyperbola when the distance of the focus from the directrix is 65 mm and the eccentricity is 3 by 2 and also draw the tangent and normal. Okay. So in our question, the given data is the curve name is given, that is hyperbola. Okay. If the curve name is not given in the question, we need to decide the curve by eccentricity value. If the eccentricity value is greater than 1, the curve will be a hyperbola. If the eccentricity value is less than 1, the curve will be a parabola. If the eccentricity value is equal to 1, the curve will be the ellipse. Okay. In our question, eccentricity value is given, that is 3 by 2, which is 1.5. The value is 1.5. 1.5 is greater than 1. So the curve will be a hyperbola. So the given data is the distance of the focus from the directrix is 65 mm and eccentricity value is 3 by 2. Okay. So first of all, draw the directrix. So what is directrix? The directrix is a fixed line and the focus is the fixed point. Directrix is a fixed line and focus is a fixed point. Let us start with the directrix. Okay. First of all, take the line command for drawing the directrix line. With the line command, draw a line. Draw a line with any distance. The distance may be a 90 or 100 or 110. Okay. Any distance, draw the line. This line name is directrix. Okay. Give the name, single line text. Click where you want and enter text height 6. Sorry. Text rotation 0. Enter. Okay. So this is directrix. This is directrix. This is directrix line. So give the naming. This point is this point is A and this point is B and middle point is C. That should be letters are not visible, notations are not visible clearly. So increase the text height. For that, I'm using match properties MA. Okay. Now it is clear. Okay, this is the directrix, a fixed line. Okay, next we need to mark the focus. We need to draw a axis line. Okay, we need to mark the focus. For that, we need to draw a axis line. So the distance between the directrix from the focus is 65 mm. So we need to draw a line with a distance of 65 mm. 65 mm. Okay. Okay. Here we have a focus point. From the directrix, the focus should be a 65 mm distance. So I'm copying A and paste it here and put a click on it. Focus will be indicated by F. Okay. So now uh, we need to divide this line into 5 equal parts. Why? Because the eccentricity value is given 3 by 2. So 3 plus 5. 3 plus 2, total we have 5. Okay. For that, we need to divide this line into 5 equal parts. So how to divide this line? By using divide command. Okay. div. The shortcut is div. Divide. Select the object. Object will be a line. Click on line and enter the number of segments, that is 5. Okay. 5 equal parts. Enter. The line is divided by 5 equal parts. Okay. So now uh, focus is uh, focus is pointed here, and directrix also we have drawn. Now we need to notate vertex. The vertex will be denoted by B. For this, so we have a eccentricity value 3 by 2. From the focus, the vertex distance is 3 units. Okay, from the focus, the vertex distance is 3 units. From the C, the vertex distance is 2 units. We have a total 5 units. Out of 5, we need to locate vertex. We need to uh, locate the vertex point, which is from the focus, 3 parts, part 1, part 2, part 3. Here, the second point. Okay, here the vertex will be placed. You'll see, control T, click on it. Okay, this is the vertex point. Okay, this is the focus. We will also make a point where directrix is drawn and the focus is also located, and vertex is also located with the help of eccentricity value. Okay. Now draw a perpendicular lines. Draw the perpendicular lines with respect to these points. Okay. Draw a perpendicular line with respect to this vertex point. Okay. Next, draw the circle. Draw the circle. P as the center. F as the radius. V as the center, F as the radius, draw the circle, VF as the radius. Okay, so center point is V and radius is F. Okay, VF as the radius, V as the center, draw the circle. Here, the perpendicular line and the circle will meet this point. Okay, this is the point E. Okay, this is the point E. Point, change it E. Change it E. Okay. So now we are going to draw a undefined line. Okay, undefined line which will meet at point C and point E. For that, we have a command ray, ray. Okay, ray command. Using this ray command, we can draw undefined line. Okay, start point and second point. So we need to click 2 points. Okay, RAY enter and point C and point E. Okay, we get undefined line. So next, we don't want this circle, erase it. Okay, erase it. And also we don't want these points, erase it. Okay, next, offset this line. We need to draw a parallel lines. We need to draw parallel lines. For that, we are going to offset this line with any distance, 10 mm or 20 mm or 30 mm, any distance. We need to offset this line. Okay, so offset command O enter. O is the offset. Okay, O enter. O is the shortcut of offset. O enter and specify offset distance. So I'm going to take 10 mm distance between these lines. So that 10 and 10. Okay, select object to object. Okay, this line I am going to offset. Click on this line. If you click this side, the object will be uh, appears here. And if you want this side, right side, click on right side. Okay, click. And I want 4 lines. 4 to 5 lines are enough for this hyperbola. Okay, I have offsetted 4 times. Okay, next. So extend these lines up to this CA line. To this CA line, we need to extend these lines. Okay. So how to extend? Extend by using extend command. EX is the shortcut. By using extend command, we can extend these lines. Okay. So click on this line and click on this line and click on view. Okay. So this is point 1, point 2, point 3. Give the notations. So see, double click on it. It's the point 1. Double click on it. Point 2. Double click on it. Point 3. Similar manner here also. Into 1 dash, 2 dash, 3 dash. So I want to move it below. And this is point 1. P point 1 dash. Point 2 dash. 2 dash. 4 dash. Here. Okay. Now, now hyperbola curve will be constructed by making a points by notating the points with the help of these radiuses. So eccentricity from point 1 to 1 dash is 3 units and point 1 to C is 2 units. Similar manner, point 2 to 2 dash is the 3 units and point 2 to C is the 2 units. So for that, we need to make a points. We need to notate the points on these perpendicular lines. Okay. So take the circle 1, 1 dash as the radius. 1, 1 dash as the radius. 1, 1 dash as the radius. And F as the center. F as the center. Make a notate a point. So F as the center. Move to the circle to this F. So the circle and this perpendicular 1 to 1 dash line perpendicular line will meet with this point. Okay, this is the point P1 dash. This is the point P1 dash. Point P1 dash. Use the same circle, move to point 2 and increase the radius 2 to 2 dash. Increase the radius 2 to 2 dash. Okay, and move this circle to F focus. Move this circle to F focus. Okay, send locate the point. Locate the point here. Here we have a point P2. Okay, P2 dash. I'm copying this P1. Control C and Control V. And double click on it and change this 1 to 2. Okay, and use the same circle. Use the same circle. Move to point 3 and increase the radius 3 to 3 dash. Increase the radius 3 to 3 dash and move to the circle to F. Okay, move to the circle to F. So we need to make a point here. Okay, this is the point E3 dash. 3 dash. And we have another line that is the 4. I want to increase the axis line length. Okay, this is the axis line. I'm going to change it axis. Okay, this is axis line. Take the circle, same circle using the same circle. Photo. Increase the radius 4 to 4 dash and move to F. Both are not in same point. There is some gap between this point 4 and focus. Okay, so here we get point 4. Point 4. Okay, so we don't want this. So we have marked 4 lines, 4 points on these 4 lines. Okay, we don't want this circle. Okay, erase it. Okay, now point dash P1 dash, P2 dash, P3 dash, P4 dash. All these 4 points we are going to mirror. Okay, mirror it. These are the above the axis line. We have 4 points. In similar manner, we need to mirror it below the axis line. Below the axis line. Okay, we have to mark these points. For that, we need to mirror these points. Okay, select all the 4 points. Okay, mirror command is MA is the shortcut mirror. After clicking this mirror command, so pick the reference, specify the first point of mirror line. We need to click 2 points, first point on C and second point on axis, anywhere on the axis line, the second point. So here the command is asking you erase source object. Always no. If you click on S, the source object, the point P1 dash, P2 dash, P2 dash will be removed. So that always say no. Okay, click on no. So we get another 4 points here. Okay, we get another 4 points. So by using spline command, we are going to join this all these points. We are going to join this all points by using spline command. So the spline command will be available on this ribbon area here, spline fit, spline, or we can also type SPL, SPL, spline. Okay. So from this bottom point and click on this vertex and point P1, point P2, point P3, and point P4. Okay, and the tangency. Click on enter. Okay, this is the hyperbola curve. This is the hyperbola curve. Now, in our question, they already asked about rather tangent and normal. They asked tangent and normal also we need to draw. So for that, first of all, give the notation below the axis line also. This is the point P1, point P2, and the point P3, point P4. So double click on it. Dash will be removed. This is the complete hyperbola. Now hyperbola is completed. Now we need to draw the tangent and normal. So for that, we need to draw a point. We need to locate a point on this curve. Anywhere on this curve, we need to locate a point. Okay. So I am locating a point on this curve here. Okay. Point on this curve. I am locating point here. Okay. Control C, control. This is a point, only point P. Remove one. From this point, we need to join a line to focus F. Draw a line from this point to focus F. Okay, take the line command from focus to from point to focus. Click on focus. Okay, and Take this line and select this line and copy it somewhere. Copy it somewhere and rotate this line into 90 degrees. Okay, rotate RO enter and select the base point and type 90. Okay, rotate. So move this line into focus point. Okay, then extend to directrix line. Directrix line. This is the point. This is the point T. Okay, this is the point T. So first of all, on this curve, locate the point. From this point to F, join a line. Copy this line and rotate 90 degrees and move to this focus line and extend to directrix. Okay, from this point T, from through this point, draw a line that is the tangent line. From this point T and point P, we need to draw a line. That line is called tangent line. Okay, take the line from the T through this P. Okay, through this P, draw a line. This tangent line. Okay. This tangent line. Similar manner, as a previous what we have rotated this line, in similar manner, copy this line and paste it somewhere. Paste it somewhere. Okay, paste it somewhere and rotate this line also 90 degrees. Rotate, enter, select a base point and type 90. Okay. And move to this point. To this point. This is the line normal. This is the line normal. We don't want this much of line. I am going to erase this portion. Okay, this line is enough. So give the line weight to both lines and give the name coloring also. This is the normal. This is the tangent. Okay, give the text using axis text. I am editing this axis to tangent, axis to normal. Normal. This is tangent. Okay, so rotate this text also parallel to this line, tangent line. Okay, and similar manner, this normal line also. Here, so this is the tangent, this is the normal. So hyperbola in general method is completed. If you understand, thank you.